Okay, so today, yeah, that should be good. Today we'll talk about molecular compounds here. Learning objectives, of course, explain the importance and need for the IUPAC system for naming compounds, molecular compounds. Using the periodic table, how and why elements combine to form compounds in specific ratios, molecular compounds. And most importantly, today we're going to predict and write formulas, formulas for molecular compounds. Okay. Molecular compounds, you have to remember, are two nonmetals. Okay, so two nonmetals. That's how we know the difference between ionic and molecular. We're going to have two nonmetals. The first one's going to be a nonmetal. The second one will be a nonmetal. Okay, they are joined together by something called a covalent bond. A covalent bond means sharing electrons. Okay, so in ionic, they transfer electrons. So the metal loses electrons, the nonmetal gains electrons. Okay, ionic. In molecular, there's no gaining and losing. There's simply sharing. Okay, and that's comes back down to Chem 20 again, and where you talk about why there's actually gaining and losing, and why some of them just share. Okay, so there can either be a transfer of electrons to fulfill that outside energy level, or there can be a sharing of electrons to fulfill that outside energy level. Okay, the octet rule, of course. In a molecule, the electrons are not transferred between atoms like they are for ionic. So covalent bonds, how do you think these two fluorine atoms achieve filled valence energy levels? How do they help each other out become basically more stable, I guess you could say? Yeah. Yeah, they kind of combine with each other, okay? And these two electrons here, so this one here by itself and this one here by itself, will be shared between both of them. Well, technically, they all will be, but they get shared between both atoms, okay? So they're being shared, and they're both Fs, of course, and those two electrons would be shared between the both of them, okay? So that's how those would take place, okay? And I think I'm going to do this for you guys for just for today, because we are running out of a little bit of time here. So hydrogen, okay? If you looked at hydrogen, okay, hydrogen has one valence electron. The other hydrogen has one valence electron. And by themselves, they are not stable, are they? Hydrogen has to have how many electrons? Look where hydrogen is, guys. How many electrons does hydrogen want to become more stable? It wants to have two, right? And each one of these only have one right now. So how do these two kind of share? Well, technically, we would say that basically they kind of overlap, okay? So they kind of do this, okay? And you might want to copy this down. And what happens is those two hydrogen atoms get very close to each other, okay? Very close. And what happens is they share these two electrons between them. So this hydrogen here has this electron, and this one here has that electron, okay? And really what happens here, just so you guys know, I mean, once again, we're drawing these atoms, and these aren't good representation of atoms, okay? They're not, because are the electrons actually right there? What are electrons doing? They're going around and around, right? They're in constant random motion, rapid motion as well. So they're going around and around. So here's how it works. This hydrogen says, hey, I got two electrons. This hydrogen says, hey, I got two electrons, and that's how they kind of pretend to have a full outside energy level. But really what these electrons are doing, they're probably doing this. You know, they're probably going around and around and around and around like this, like that. And at any time, there'll be an electron here, perhaps an electron here, and the hydrogen's like, hey, I have two electrons, and this hydrogen's like, I got two electrons, and this one's like, I got two electrons, and they're like, hey, I'm more stable, and the other guy's like, I'm more stable too, because we're helping each other out become more stable. It's like the buddy system. I don't know. It's not really like the buddy system at all, but anyway, you know what I'm saying. Okay, so they're helping each other out become more stable. Okay. How do you think two hydrogen atoms and one oxygen would share electrons to form a stable octet? Okay, How do you think that would happen? Let's see. Let's think about that for a second. 2 hydrogens and an oxygen. Okay? You know what I think? We should probably start with some Lewis diagrams, yes? Or electron energy, or sorry, Lewis, we haven't, no. We'll start with Bohr diagrams, yes? Yes. We'll start with maybe a Bohr diagram, for example. How many electrons does hydrogen have again? Okay. So there's its 1 electron, yes? Okay. And apparently we have 2 of those, 2 hydrogens. So maybe another one here somewhere. Okay. How many does oxygen have? 8 altogether, yes? Or actually, how many in the outside energy level, though? 6, right? So we got 8 protons, 8 neutrons. First one's filled, that's 1, 2. And then the second one has 1, 2, 3, 4, 5, 6. How do you think those share? Do you see some sharing there going on? Yeah, look. Could these, maybe these 2 could share between them, yeah? I could share those, yes? And I could probably share these here, yeah? So I could kind of share those, and I could kind of share those, yeah? And that's actually what water kind of looks like. It's kind of got this bent shape to it, kind of we call it. And they would share those electrons between the 2 of them. So hydrogen would be sharing with oxygen, and oxygen would be sharing with hydrogen there, and they'd be sharing those electrons, okay? If oxygen kind of has these 2, look, and those 2, then oxygen has what? 6, 7, 8, yes? And then hydrogen, of course, has 2 here, 2 here. So hydrogen's happy because it's like it's got 2. The other hydrogen's happy because it's like it's got 2, and then the oxygen's happy because it's got like 8. Okay. In a covalent bond, electrons are shared between atoms, so the octet rule can be classified or satisfied. Remember, with molecular compounds, sharing is caring. All right. Naming molecular compounds. How do we name molecular compounds? So, the answer is, well, we only really worry about the 2 atom ones. Okay, we don't do anything other than that. So we're not going to do anything complex. We're only going to have 2 atoms. Okay, so we're going to write the name of the first element. Listen closely. So the name of the first nonmetal. Okay. We're going to write the name of the second one, but we're going to change it to "ide." Okay, so like we've done before, kind of thing. So like oxide, sulfide, chloride, bromide, etc., etc. If there's more than one of the first elements, so if we have one or more of the first element, we need to use a prefix. Okay, so like 2 or 3 or 4, we'll use a prefix. The second element always needs a prefix. Okay, and we're going to go through lots of examples here, so please pay attention, ask if you got any questions. So the first one, the only thing with the first one is we just name it like it is. We do not need a prefix if it's 1, but if it's 2 or more, yes. The second element, we always need a prefix. We always need to put "ide" on the end. Okay, yep. Yep. Okay. The Greek prefixes or the prefixes are the following. Mono, you're going to write these down. Di, tri, tetra, penta. Okay. Hexa, hepta, octa, nona. Oh, nona. Oh, nona. Or is that nana? I don't know. Deca. Okay. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay. Are the Greek prefixes, or just basically the prefixes that we use. Okay. So we need to be aware of those. We do need to use prefixes with these. Okay. So these are not, anytime you have prefixes, they're not ionic, yes? They're molecular. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Good? Yes? Okay. Moving on, yeah? Is that okay? No? Yes? Okay, here we go. So, why are prefixes necessary? Well, we have a variety of compounds that can form between two nonmetal elements, so we need to specify which is being formed with prefixes. So if you look at these three compounds here, we got NO, okay, and NO2 basically, something like that there, and actually there's probably a few different ones here as well. So we need to have prefixes in order to tell you how many of each atom we have. So here's the deal. Actually, I think we're going to get to it anyway here right away. But, well, maybe we won't. You know what? We'll leave it for now. That'll be fine. So here we go. Let's name these ones here. Okay, so let's name these. CS2, the 2 should be at the bottom, yes? So this one here, okay? That's a nonmetal. So of course, nonmetal, I think right away the first one's a nonmetal. This is molecular. So I need to use prefixes, and I need to be thinking that kind of thing there. Caring, sharing, yes? So that is carbon. We do not need a prefix with carbon because there's only one. So I'd say this is carbon. 2, I always need a prefix for the second element, always. So this is 2 sulfurs, so that is sulfur, but that turns into sulfide, yes? So sulfur, sulfide, and I need a prefix. Kind of sounds mean, doesn't it? Disulfide. Disulfide. Okay? Good? Now, this one, N2O4. Okay? So once again, more than one nitrogen here, so I do need a prefix. Yes? So this would be dinitrogen. 4, that's tetra. And then oxide. Oxygen, oxide. Okay? And we're going to skip this part here. Okay? So dinitrogen tetraoxide. Good? Questions, anyone? So we do need to use prefixes. Like I said, 2 or more for the first one, prefixes. Always on the second one. Okay? If you're writing the formula, the prefix is going to tell you how many of each one we need. Yes? So, and here's the important part. We never reduce the subscripts. So this is really, really easy, guys, as long as you know the prefixes. If whatever the prefix is, that's what we just put the number down. So if you know that penta is 5, then it's 5. Okay, it's easy. There's no swap and drop. There's nothing. It's just whatever it is. Okay. So like for example, sulfur dioxide. Sulfur, 1 sulfur obviously because there's no prefix. Sulfur. 2 oxides. 2 oxides. That's it. Okay? All right? Dinitrogen. So dinitrogen, that's dinitrogen, N2. Okay? Remember that prefix goes with nitrogen, so they go together, N2. Trioxide. You'll like it. O3. Trioxide. Okay? Good? Okay? So that's all you need to do. Dinitrogen, N2. Shh, guys. Trioxide, O3. Okay? All right. By the way, there's some elements that, of course, exist in pairs. These are called molecular elements. Okay? Molecular elements. Just so you guys know, in Chem 20, we just call them molecular elements. We don't have we don't get into polyatomic. We just call them molecular elements. And remember, these elements happen the way that they do because they're more stable. Okay? So, like you know what? I'm going to give you a little option here. And there's a few little things here, but I'll tell you this. Like hydrogen. Hydrogen, when you're walking down the street, you see 2 of them together. And the reason is because they're helping each other out become more stable. Okay? So hydrogen has one valence electron, right? I'm just going to use a dot here to represent that. And hydrogen has one valence electron. And they're basically helping each other out become more stable. So when those two hydrogens get close enough together, they share those electrons. That's why you always find hydrogens in twos when you're walking down the street. Like, hey, look, hydrogen. Which is funny because you can't see that, but trust me. Okay? Like, hey, two hydrogens are connected together. Okay? So that's what's happening. There's something called the molecular elements. There's diatomic ones. Honestly, I just like to call them molecular elements. Okay? Molecular elements is good enough. And how I remember the molecular elements, in other words, they come in more than one. So you can see H2, N2, O2, F2, Cl2, Br2, I2. And P4 and S8 are the ones we usually talk about. How I remember that is a little different than this here. And I think we'll just maybe, yeah. Here's how I remember them. Molecular elements. You might want to write this down, mate, or because there is that as well, but molecular elements. There is 9 that I usually consider to be the molecular elements that we want to kind of focus on. And how I remember them is this: I2, H2, N2, O2, Br2, okay? So those are the molecular elements there. I'll move it up here right away. I should have maybe molecular elements. Molecular elements. There's 9 of them, okay? Molecular elements. And that basically means like, hey, when I take a breath of oxygen, you're not getting O atoms, you're getting O2 atoms. You're getting 2 of them at the same time. Okay, that's oxygen. All right, so you're breathing in O2 or N2 or H2, okay? A lot of these molecular elements, like I said, they pair up to help each other become more stable. And how I remember this, I still remember this from like grade whatever, a long time ago, when I was in like school, like 2008. That's not supposed to be funny. Not supposed to. How I remember it is I have a little acronym we call this. That's English. I'm multi-talented. Okay? I have no bright. Oh, geez, I screwed that up. I'm not that talented. Okay? Let's try that again. Sorry. Doesn't matter. Well, it kind of does for the effect. I have no bright or clever friends. Some of you guys are like, hey, this is true. And your friends are like, wait a minute. They're thinking about the same thing about you, so don't worry. Okay? I have no bright or clever friends. People. Stupid. And I don't know why. It doesn't really make sense at the end there, but it's kind of always stuck with me. It's stupid, and it kind of just works, you know? Like, I don't know. It just kind of, I don't know, I just always remember that for some reason. I have no bright or clever friends, people stupid. But that's how I remember them. And then there's the other one that's in the notes there as well. But these are the elements that you would find if you're walking down the street and you're like, hey, it's chlorine. Chlorine would come in 2s, okay? F comes in 2s because they're helping each other become more stable. They're sharing electrons to fulfill that octet rule, okay? When naming ionic and molecular compounds, you must decide if it's molecular or ionic. How do you decide if it's molecular or ionic? Yeah. Metals and non-metals would be, well, no, like if, Yeah, if it's metal and then a non-metal, it'd be ionic, right? And then if it's two non-metals, right? Non-metal, non-metal, molecular, right? Yes? How else can you tell? What if I had the formula written out, like, or not the formula? What if I had the name of that compound written out? How else would you tell? The what now? Yeah, prefixes are for molecular, right? Okay. You wouldn't be using prefixes with ionic, right? So that's the difference there as well. Okay. So today you're going to get a mixture of ionic and molecular together. So the first thing you better decide is this ionic? Is this yesterday's homework? Or is this molecular prefixes kind of stuff? Okay. So that depends really. What actually does it depend on? You can tell very, very quickly. What's the first thing that's going to tell you if it's ionic or molecular? The very first thing. No, before that. First element. Well, and could be prefixes, I guess, depending on what you're doing. Prefixes, right? Or the first element. Because if the first element's a metal, it's ionic. If the first metal, or if the first element is a non-metal, it's probably sharing, it's molecular. Okay? So, keep that in mind. So, there you go. Okay? Only non-metal atoms. All right? Yeah, don't worry about that. Once again, and don't worry about those either. That's fine. Okay, good? Yes? All right. So you guys have some homework there.